This is the video for the price game. Here is the blue note box. You select a row of the profit matrix and your competitor selects a column. The selected cell has the profit. Well, here it says profit matrix. It has 5 rows and it has 5 columns. You can randomly select rows by setting a relative frequency for each row. A row percentage will then be created. Well, here it says relative frequency. All the yellow bars are the same length, and here it says the value of their length is 10, and all the percentages are the same, 20%. Change the relative frequency by setting the length of the row's yellow bar. Longer bar equals higher percentage. Well, then it says click in the red relative frequency box to make your changes. This determines your strategy for the game. Well, let's say I wanted the relative frequency of the first row to be higher, so I'll click out here. Now it says its value is 48. The others are still 10. So it says the percentage of time that row 1 will be selected is 56% of the time, and the others will each be 11% of the time. That changed because we changed the length of this bar to a different relative frequency. Your competitor selects a strategy that sets a fixed expected profit, no matter what strategy you select. Well, here the expected value now is 3,904. And down here we see the competitor's strategy in green. He picks the first one 16% of the time, the next one 17, then 21, 21, and 25% of the time, where you are selecting them 56% for the first row and 11% for each of the other rows. There are 100 games, and their numbers are 0 to 99. Here is where you select the number. Now I'm going to change the number, say, to number 10. Alright, the profit matrix changed, and look down here, the competitor's strategy had to change because the profit matrix changed. Now instead of this being 16%, it's 20% for the first column. Alright, I'm going to change it back to 0. And it says click on next below this line for more notes. So I'm going to click next. Below the profit matrix is a matrix that shows the percentage each cell will be selected. Alright, down here that is. Here's where the competitor's strategy was. Here's your strategy. And it calculated the percentage of time each cell will be selected. Here it says, at the top of the matrix is the competitor's strategy. This is the percentage of time the column is selected. On the left of the matrix is the percentages for your strategy, the percentage for each row selection. Here they are, 56 and the 11s. Multiply the row percentage by the column percentage to get the percentage of time the cell is selected. 16% of 56% is 8.96%. And if we summed up all these percentages, it should come to 100%. When you sum up the total of these percentages times their profit, you get the expected value for the game. And here is what that expected value is. If you multiply this 8.96% times the 8,000, 9.52% times 56.45, all the way to the end, where you would be 2.75% times the minus 548, you're going to come to this value, 3,904. The competitor changes his strategy for each game. Remember, when we changed the game number, it changed this 16% to 20%. Well, now it says we can click next again. Here's another note. The profit matrix was created in a way that would allow for the competitor's strategy to select each column. In other words, this matrix was designed so that the competitor would pick each one of the columns. That is not always the case, and here it says there are times when only one column would be selected, or 2, 3, or 4 of the 5 columns. On the bottom left is the average profit found after 4,000 games were played. Well, down here is what it means. The average result after 4,000 random tests is 3,887. Well, they were chosen randomly, so it really didn't get to the average of 3,904. Also, there is a value for each row showing its expected value given the competitor's strategy. Well, that's down here. Given the column percentages, the sum of each row, and it's all the same. I mean, that's why no matter what row you pick, the competitor's strategy will make it come out in the long run to 3,904. These values should be the same since the competitor wants a fixed expected value. Okay? To learn more about this subject, enter game theory in a search engine. That is what this is about. This is a game of game theory. Now I'm going to click on Program in this red stripe at the top. Here is a listing of the program that is running. It actually consists of 3 different programs. Over here it lists them. The price game is the main program. The first subprogram is titled Build 100 Games, and the second subprogram is titled Display the Game and Solve It. Up here at the top, there are options that you can use when making this game or making any application using this P code. Down below here, there are brown boxes that help you make a program by putting comments in it and changing the names of variables, captions, telling you about ASCII and colors and whatnot. To learn how to build an application, here is a videos on how to build an application. Below that is another video that's about actions. Oh, I'm sorry. This is actually an application that teaches you about actions. Below that is this list of HTML5 P code YouTube videos about creating applications. Alright, I'm going to go back up here and click on this blue box, execute the application, and we will return to the game. Here we are back to the game. At the bottom of the display of the game is a list of HTML5 P code apps. These are basically other games, other applications that is, that you can run into P code. And each one of them will allow you to create another application and tell you how to make applications. Alright, this is the end of the video on price.